Hi guys, I'm so glad that you could join us today for our grade 12 revision on patterns and sequences. Okay, so as always when we're doing these revision sessions, I like to start off the lesson by giving you a little bit of an exam tip. So today my tip for you is to remember that you are writing the exam for the examiner to mark. Right? That is very, very important to remember because you need to keep that in mind. While you quickly rushing in a mad panic to get your answer down, they still need to be able to make sense of what it is you wrote down. So they're not going to call you up and say, "Hi, what did you mean to write here?" No, they aren't. So you need to keep that in mind. You need to set out your work in a neat way so that they can follow easily. You need to show all your calculations and keep your processes in an orderly manner so that it's easy to follow your logic and easier to give you marks where you need them. All right, so remember that. Keep that in mind when you write out your working in your exam. All right. Just talking about the breakdown for your exams, when we're talking about patterns and sequences, these account for roughly 25 to 28 marks in your final exam, and that's approximately 17% of paper 1. Okay. So it is a section you start off with right in the beginning of the year, and by this time of the year you are going to need a bit of reminding of the formulae you're going to use. So that's what we're going to look at first today, is just remind ourselves what are the key concepts and the key properties of arithmetic sequences, geometric sequences, and the formulae that we use. Okay, let's go through that. So remember, in an arithmetic sequence, what we always get is a common difference, which we call D, between any two consecutive terms. So your common difference D is given by, and it seems like our little n's have moved down the line there, but it's given by Tn minus Tn minus 1. So basically, it's the consecutive terms that you are looking at, and you're taking the difference between those terms and making sure that they are the same, and that will give you your common difference. Remember the general form for an arithmetic sequence, you're adding a common difference each time. So you start with the first term A, and then you add on the difference to get your second term. So T1 will be A, T2 will be A plus D, and then term 3 will be A plus 2D. So each time you add a D to get your next term. The general formula that you'll remember for an arithmetic sequence in order to find any term in the sequence, the general term is Tn is equal to A plus n minus 1 times D, where A is your first term. The subscript n, remember that refers to the term position in the sequence. N minus 1, n is your number of terms or your term position, and D is your common difference. If you were to graph the sequence, so if you were to put down your sequence, your linear sequence or arithmetic sequence on a graph, and you had to plot your points, you will see that those points lie on a straight line. Okay. Then one of the sequences you learned in grade 11 was the quadratic sequence, and there you saw that there wasn't a common first difference between terms, as in the case of arithmetic sequences, but there was a constant second difference between any two consecutive terms. The general formula was Tn is equal to an squared plus bn plus c, and if we had to graph this sequence, it would lie on a parabola or a quadratic function. All right. Now, when we look at a geometric sequence, which again you deal with in grade 12, you'll see that there's a constant ratio R between any two consecutive terms. And I must apologize here, everything has moved all over the place. But basically what we're saying is to work out your ratio, it's your term n divided by the term just before it. So divided by term n minus 1, and that's how you would work out the constant ratio. Obviously, that will be the same in a geometric sequence throughout the sequence. The general form for a geometric sequence, you start with your first term A, and then you multiply by R to get the next term. So it's A, and then your next term will be AR. All right, and in fact, those plus signs, let's just make them semicolons because we're dealing with a sequence, not a series. So we've got A, and then the next term would be AR, and the next one AR squared, and so on. The general formula we use for geometric series or sequences rather is Tn is equal to AR to the power n minus 1. Okay. While we are talking about a sequence and a series, because I've obviously, so you've seen that on your screen, you've had plus signs for geometric sequence instead of just your semicolons. What you need to remember, the difference between a sequence and a series. A sequence is an ordered list of numbers, so they're usually separated by semicolons, whereas a series is a sum of numbers. So you will have, if we're talking about a geometric series, you'll have A plus AR squared, and so on. Okay, so a series, you are adding those terms together. A sequence, it's just an ordered list of numbers. Okay, so that's the difference between a sequence and a series. If we had to graph the geometric sequence, we will see that all the points will lie on an exponential curve. All right. Now let's talk about sigma notation. So if we're looking at the sum of a sequence TR or a series TR, remember whenever you're dealing with sigma, we're talking about adding things together. So that means we're dealing with a sum. When we're talking about a sum, we're talking about a series. So sigma notation is used to indicate the sum of terms given by TR, whatever your series is, starting from when R is equal to 1 and ending at R is equal to n. So usually we'll have something here that goes R is equal to 1 and it goes up to n. Okay. A series, as I've mentioned before, is the sum of terms in a sequence. Now, when we're looking at arithmetic series, the two formulae we can use, we've got Sn is equal to n over 2 times a plus l, where l is the last term. So if you've got the last term in your arithmetic series, that's the one that you would go for. It's quicker than the other formula, which is Sn is equal to n over 2, 2a plus n minus 1 times d. That whole thing is also given to you on your formula sheet. A geometric series, you've got two different formulae. If r is less than 1, you'll notice that Sn is equal to a in your numerator, you times by 1 minus r to the power of n. And if r is greater than 1, then you've got r to the power n minus 1. It just makes dealing with the signs a little bit easier as well. And when we're talking about a geometric series that converges, then we are able to work out the sum to infinity of the geometric series. And remember that in order for a geometric series to converge, your ratio, the constant ratio, needs to be a number between minus 1 and 1. The formula for the sum to infinity, a over 1 minus r, and you need to have r between 1 and minus 1 in order to find a convergent geometric series. All right. So what that means is if you have a convergent geometric series with a ratio in that interval, that series will then tend to a certain fixed number as the number of terms tends to infinity. Okay, so that is why we need to always make sure and check that our ratio conforms and falls into the right interval before we go into using the sum to infinity. All right, so the best thing to do is to go through quite a few examples and go through past papers as you start preparing for your exam. You know, you want to get to the point where you perfect at answering questions on patterns and on sequences, and you know the only thing that makes you perfect in maths is practice, right? So I've got the first question that I'd like you guys to have a look at for today. This comes straight from the June-July 2015 paper. It is question 2, Maths paper 1. If you've got the paper or if you can Google online find the paper, that's the one to look at. Otherwise, you're simply going to look at the sequence, the arithmetic sequence that's given on your screen. And what I'd like you to do is to take down the key information that you need, find your common difference, and look at the questions and see how you would attempt to answer them. So we're going to give you 2 minutes to have a look at this. Right, guys, so this question here, all you had to do was take down the key information, work out your common difference, and see if you could make sense of what the question was asking you to find in each part, okay? Let's go through it together. We want to get through all of these questions if possible. Okay, so you were told that the first three terms of an arithmetic sequence are 4, 13, and 22. You were asked to write down the fourth term of the sequence. Now, in order to do that, you need to work out the constant difference. Now remember, they did tell you it's arithmetic, so you already know that your constant difference is going to be given by term 3 minus term 2. That will give you the same answer as term 2 minus term 1. Okay, you can always do a quick check for yourself to see that it is an arithmetic sequence, but chances are if it's in an exam, they're not going to lie to you, and it is an arithmetic sequence. Okay, so term 3 is 22. Term 2 is 13. 22 minus 13 is 9. If you chose to do T2 minus T1, so if you did 13 minus 4, you would also get a constant difference of 9. All right, so if I want to find the fourth term of the sequence, the easiest way to do it is to just add 9 onto my third term instead of using a formula. So 22 plus 9. So we get term 4 will be 22, which is term 3, plus 9, and that's going to give us an answer of 31. All right. Okay, let's go into the next one, 1.2. Determine the general term of the sequence. Now here you need to remember that your general term is given by, in an arithmetic sequence, Tn is equal to A plus n minus 1 times D. Okay, so the general term will help you to find any term in this sequence. So you're not going to substitute specific values for n at this point. You want to get a general idea of what the term is so that whatever term you are asked to find, you'd be able to do it using this expression that you create for the general term. Okay, so all we're going to do here is substitute our value of A, which is 4, plus n minus 1. We don't put anything in for n because we're just looking at the general term. And then our constant difference was 9. All right. So let's simplify that. I get 4 plus, multiply the 9 into the bracket. So I get plus 9n minus 9. And if I simplify further, 4 minus 9 is minus 5. So therefore my general term is 9n minus 5. Okay, at this point you should all be really sailing through these questions. I hope that you are, and that you're understanding that part of the work really, really well. It is the basics of arithmetic sequences. Okay, let's quickly see if we can squeeze in the next question before we need to take a break. All right, so 1.3 says, consider the terms of the sequence which are even. Calculate the sum of the first 25 terms which are even. So when we're looking at the even terms, let's look at our sequence. We've got 4, 13, and then the next one was 22. We saw that term 4 had a value of 31. And then term 5, if I add 9 onto 31, will give me 40. So what I see is that every second term in this sequence is even. So the terms 4, which is term 1, term 2, which is actually term 3 in the original sequence, is 22 in our even number sequence. And then the third term in our even numbered sequence is 40, which is term 5 in the original sequence. So term 1, 3, and 5 from the original sequence make up term 1, 2, and 3 of the even numbered sequence, all right? And so I can see to get from 4 to 22, there's a common difference of 18, and then to get from 22 to 40, there's also a common difference of 18. So certainly we are dealing with an arithmetic sequence once again. So they asked us, calculate the sum of the first 25 terms. So I'm going to use my formula, S25 is equal to n over 2, where n is 25, into 2 times a is 4, plus n minus 1, so 25 minus 1, times the common difference, which is 18 now. All right, so I get 25 over 2 into 8 plus 24 times 18. So at this point you whip out your trusted calculator and let's plug that all in and see what we get. All right, so I've got 25 and I type in over 2. All right, so just remember, guys, that it's very easy to make silly mistakes on your calculator, and it's very quick to double check if your calculator work is correct. Just simply do the same steps twice. So always double check your calculator working. And we get 5,500. All right, so that's the sum of all the even terms up to term 25 of this new sequence. Okay, I think that's quite a lot of information for you guys to take in. So let's take a quick break before we finish off this first question for today's lesson. We're back after this. Hi again, welcome back from that quick break, and now we're continuing with the first question we were looking at, and we were looking at a question that came from the June-July 2015 paper. This was question 2 in paper 1. All right, so the last part that we had to answer of this question, and we want to go straight into this while it's still fresh in our minds, we were told that the original sequence with the terms 4, 13, 22 forms the first differences of a new sequence with a first term equal to -6. Determine a formula for the nth term of this new sequence. So once they start talking about first differences, in my mind I automatically start thinking, well, what is the second difference going to be then, right? This is then starting my mind thinking about quadratic sequences, because we know when we're dealing with second differences, we're looking at quadratic sequences. So you need to already start thinking about how this fits into a section in number patterns and sequences that you already know. Okay, so in this question, I know that we're dealing with a quadratic sequence. So this is 1.4. They tell you that the first term of this quadratic sequence, this new sequence, is -6. All right. And they tell you that your first differences are given by that sequence that we've just worked with, 4, 13, 22. All right, so 4, 13, and 22 are the first differences of this new sequence. Now, for me to get to a point where I can use the general form of a quadratic sequence, which is Tn is equal to an squared plus bn plus c, I need to figure out what the other terms, well, maybe 3, maybe 2, but we need to go further than -6. We need at least 2 more terms so that we can work with this general formula. All right? How do we find the other 2 terms? Well, all we're going to do is we're going to simply say, well, I need to go forward. So for me to get the next term in the sequence, I need to add the first difference. So -6 plus 4 will give me -2. Okay, to get the third term now in this new sequence, I'm going to say I need to take term 2 and add the first difference of 13. -2 plus 13, what is 13 minus 2? That is 11, right? And then to get the next term, we're going to say 11 plus 13, and that will give us, what is 11 plus 13? 1 and 1 is 2, 1 and 3 is 4, so that will be 24. Okay. All right, sorry, I made a mistake there. Luckily, we picked it up now. We're going to say -2 plus 13 gives us 11, but then to get the fourth term, we would say 11 plus 22, which will give us 33. Okay, and we could continue actually with the sequence, because what we already know is that the second difference is going to be 9. We've already worked out 4, 13, and 22 was a linear sequence with a constant difference of 9. So we already have the second difference for or of this quadratic sequence with terms -6, -2, and 11. Okay. So now we've got to start thinking, well, I need to work out that general term. In that general term, we see that we need to work out the values for A, B, and C. How do we do that? Well, let's start with A. Now, one of the things you'll have to do when working with quadratic sequences is you'll need to remember that to work out the value for a, it's your second difference divided by 2. Okay, and there is a process that you go through to derive and to prove why the value of a is your second difference divided by 2. We're not going to look at proving that, you just assume that and then you move on and use that value for a to help you work out your general term. So a in your general term is going to be your second difference, which is 9 divided by 2. So I've got the value for a in my sequence. I've got Tn is equal to 9 over 2 n squared plus bn plus c. Now, there's different methods to work out the values of b and c. The most commonly used method is to use simultaneous equations. And what you have to do is, some people say, well, remember that term 1 in that sequence is given by a plus b plus c. Remember that term 2 is given by da 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 da. We don't have to remember those things. We can work them out, okay? Because how do we work them out? Let me show you. If I want to know what the value of term 1 was, I would simply substitute into my sequence an squared. I'd put 1 in place of n. And that would give me the value of term 1. So you can see that I can work out the formula for the first term by simply substituting 1 into the general term. So the formula that gives me term 1 in any quadratic sequence is a plus b plus c. We can use that to help us work out one of the equations that we need in our simultaneous equation setup. And then term 2, all you're going to do is you're going to replace n with a value of 2. So term 2 is given by a times 2 squared plus b times 2 plus c. So that will give me 4a plus 2b plus c. All right, so the expression for term 2 is given by 4a plus 2b plus c in any quadratic sequence, and the expression for term 1 is given by a plus b plus c. Now you simply have to use the sequence that you are considering to help you work out the values for a, b, and c. We've already seen that the value for a in this sequence is 9 over 2. I know that the first term has a value of minus 6. They gave that to me. So I can use that information and substitute into that equation of T1. T1 has a value of minus 6, but it also has a value of a plus b plus c. So therefore, I can replace a with 9 over 2 plus b plus c is equal to negative 6. In a similar way, you can say, well, term 2 is going to be given by 4 times a, and 4 times a was 9 over 2, plus 2 times b plus c is equal to, well, we saw that the value of term 2 was minus 2. So we equate that to minus 2. Okay, we're then going to solve these simultaneous equations. Let's simplify it a little bit. So we can see that term 1 will be given by b plus c. So I'm just going to write this underneath here. b plus c is equal to minus 6 minus 9 over 2. Simplifying for term 2, 4 times 2, well, we're just going to be left with 4 times 9 over 2, sorry. It's going to leave me with 2 over 1 times 9. So I'm going to get 18 plus 2b plus c is equal to minus 2. So therefore, we can then choose either we're going to work with equation 1 or we're going to work with equation 2. Let's just simplify a little bit further. I'll get, if I decide to work from equation 1, we're going to get that b is equal to minus 6 minus 9 over 2. Well, minus 6 is the same as minus 12 over 2. So minus 12 minus 9. Okay, you can actually do all of this on your calculator if you prefer. I know some of you are now saying, oh, let's just use a calculator. We're looking at dreaded fractions. Please, if you feel like you'd rather use a calculator, go ahead and do that. So if we don't use a calculator, we still get the same answer, obviously. Minus 12 minus 9 is going to give us minus 21 over 2. minus C. We can then take that value and substitute it in place of B into this equation. All right, guys, I'm going to quickly go over this working with you, and you can fill in all this information for yourself, but I quickly want to show you what the steps are so that we can finish this off, and you can finish this off for yourself as well. So after substituting in place of B in your second equation, so we substitute equation 1 into equation 2, you're going to get something that looks like this. And then when you simplify that, let's see what you get. Okay, you go through that whole process and you will get that the value for C is equal to minus 1. And you'll get the value for B by substituting that value for C back into your equation 1. You will get that the value for B, and you can see I've skipped out all the steps, and you guys can do that for yourself. And we'll get B is equal to minus 19 over 2. All right, so getting the whole simultaneous equation done, that requires a work that most of you are very familiar with now. We basically substitute from equation 1, substitute into equation 2, and then once we get our answer for C, we're going to take that, put it back into equation 1, and solve for B. All right, I want to show you another way quickly to work out the value for C, which I think is easier. I went through the simultaneous equation method because most of you use it. The way I would work out the value for C is, remember that we relate this quadratic sequence to a quadratic function. And remember, on a quadratic function, the value of C is actually the y-intercept. So if we relate that back to a quadratic sequence, C is actually term 0. Okay, so the value, if you think about it, it's where the graph is going to cut the y-axis. So how I would work out the value of C, and this is just an alternate method, okay? You can do simultaneous equations. This is an alternate method. C is actually equal to term 0, okay? That means it's the term before minus 6. It's the term that fits in that slot there, because remember, your sequence starts from term 1 onwards. So for me to work out the value for C, what I would do is I would work backwards. Okay, so this is how I would work backwards. You saw that your second difference is 9. All right, we saw that the constant difference there was 9. So for me to go backwards, I need to figure out what is the first difference in this line before 4. Okay, so how do we get that value? Well, if you go 13 minus 9, you get 4. If you go 4 minus 9, you get minus 5. So that is the term 0 value in your first differences. For me to get backwards and get term 0, I then say minus 6 minus that term will give me term 0. So minus 6, so term 1 minus my first difference would give me minus 6 plus 5, which is minus 1. And that's how I would work out C. It's more of an intuitive method. It's very much quicker than doing the simultaneous method, but it really just depends on you which method you prefer to deal with. All right, we've done quite a lot of work on this question. We've spent a lot of time just on this question. I want you to have a chance to go through another question now, also from that same paper. Let's have a look at question 2. So this is question 3 from that same paper. I want you to have a chance to just take it down, write down the key information that you can gather from that sigma notation. Guys, you've got 3 minutes to take this down. Okay, guys, so I want to quickly start this question before we go for a break. I just want to give you an idea of how to approach the question, and then you can have a look at it during our next break. But let's quickly read it. We've got that we are given sigma, which means we are finding the sum. So given that the sum from p is equal to 4 to 21 of the series minus 3 to the power of p, write down the value of the first three terms of the series. Well, you notice that you've been given the series that you are dealing with. You see that p is starting from 4. So therefore, to write down the first three terms, we're going to look at the series minus 3 to the power of p. To find the first term, remember you're starting from when p is 4. So term 1 is actually going to be minus 3 to the power of 4. So in place of p, you replace the first term that you are starting with, so when p is 4, and you'll get 81. Okay, so term 2, the next term in the series, so we've started at 4, the next one's going to be to the power of 5. Minus 3 to the power of 5 will be negative 243. And then for term 3, the same thing. We're now moving on. We started at when p is equal to 4, we move to p is 5, and now it's going to be the value when p is 6. And you'll get an answer of 729. So the first three terms of this series is 81, and then we've got minus 243 plus 729, and that's going to continue. All right, and it will actually probably be a negative. Okay, but you're basically going to just write down your first three terms using the fact that they gave you the formula for the series. Okay, and you're just simply substituting. All right, guys, let's take a quick break. Now that you've got those first three terms, it will probably help you to work out the rest of the question. After this break, we'll finish this off quickly and hopefully sneak in one more question. Back after this. Welcome back, guys. In our last segment, we're going to quickly finish off the question we were doing before the break and then hopefully do another one as well. All right, so let's go straight into 2.2. This was now saying calculate the value of the constant ratio. Okay, so all you're going to do there, remember when you're working out your constant ratio, it's term 3 divided by term 2 gives you the same answer as term 2 divided by term 1. So I'm going to take 729, which is term 3, divided by term 2, which was negative 243. And you will get that your constant ratio is negative 3. If you do term 2 divided by term 1, you'll get the same answer. 2.3, will the series converge? Explain your answer. Well, remember, for a series to converge, your ratio needs to be in the interval between 1 and minus 1. And our ratio is negative 3. Negative 3 is less than negative 1. Therefore, this series will not converge. Okay, so it's not going to converge. All right, and then the last one here. Calculate the sum of the series minus 3 to the power of x times x. So there's now an x joined here to your series, and give your answer in terms of x. Okay, so at first it looks really, really complicated, but we're going to look at it in parts and understand what it's saying to us. So we're finding the sum of the series from p is equal to 4 to, what was it? I think it was 21. Of the series minus 3 to the power of p, and then now they've put an x in there. Okay, now remember, all the x is really going to affect, if you start thinking about the formula for the sum of a geometric series, what this value of x is really going to affect is the value of a, in terms of what we're going to use in that formula. Okay, so it looks more complicated than it really is, but if you work through the process, through the logical process, you will see that the only thing it affects is the value of a. All right, so let's have a look. Well, the only thing that we are going to use, obviously it affects the whole series, but the only thing we are using in this formula. All right, So first let's just work out, and I want to just remind you to work out n, which tells us how many terms we're dealing with. We're going to say the top number minus the bottom number where we're starting, and then we add 1. Okay, so 21 minus 4 is going to give me 17. 17 plus 1 is 18. So we're working with 18 terms, and the formula we're going to use, sum of 18 is equal to a into 1 minus r to the power of n all over 1 minus r. The value of a now, to work out the value of a, what we're going to do in that series, we're going to replace p with 4, and we're going to get that this new a will be minus 3 to the power of 4x. So that's going to be 81x. So the value of a is 81x. The value of r is actually going to stay the same, because what will happen is with these new terms, each time you'll be cancelling the x out. So your ratio is still going to be minus 3. So r is still going to be minus 3 to the power of n, where n is 18, divided by 1 minus 3. All right, so you can keep the 81x outside while you work out that little portion there on your calculator. You will then multiply that whole thing by the 81. You can do all of that on your calculator, and you're going to get this following massive answer, minus 78452648882x. Okay, so that is quite a big sum that you end up with, and all you're going to do is just work all of the numerical values out in your calculator, multiply by x, and that's it. All right. Okay, quickly guys, as you can see, we are running out of time, so I quickly want to go into the last question for today. This comes from your DBE Maths Paper 1, November 2015, question 3. I'd like you to take down the sum that I'm giving you, take down that series and see what you can work out, see if it's arithmetic, if it's geometric, what you can work out, the value of r, the value of d, and you can have a read through the questions. Hopefully we'll have enough time to finish this one off, but we're not going to have enough time if I don't let you get on with it. So we're going to give you 2 minutes to have a look at this. Okay, everyone, it's our last question for today. Let's get straight into it. We've got the series given by the terms minus 3 plus 5 plus 13, etc. This goes on to n terms. They asked us to work out the general term of the series in that form. Okay, so all we're going to do, the first thing we need to do is we're going to work through it as if it were just a normal arithmetic sequence and see where we get. Don't let the K's and the B's and all of that scare you. Okay, so I've got minus 3 plus 5 plus 13 plus 21. You would work out the value for D by either saying term 2 minus term 1 or term 3 minus term 2, etc. And you'll get that your constant difference is 8. All right, so D is equal to 8. Now you know that the general form of an arithmetic sequence, we see that it is an arithmetic sequence, is Tn is equal to A plus n minus 1 times D. They've asked you to write it in a specific form, which is Tk is equal to Bk plus C. Okay, and remember that those variables are just placeholders, so it shouldn't be a problem at all. So Tk is equal to Bk plus C. Okay, so I can say, to get it in that form of Tk is equal to something, I'm going to have, well, Tk is equal to A was minus 3, plus n minus 1. Instead of n, we're going to use k, so that we use the same variable as what they've asked us to, and then D had a value for 8. You can then simplify this, and you'll get an answer, minus 3 plus 8k minus 8. That's going to give you an answer of 8k minus 11. Okay, and that's the correct form of what they asked you to make this look like. Okay, the next one, 3.2, write Sn in sigma notation. So in order to use sigma notation, I need to know where am I starting, where am I going to, and what my series is. So for 3.2, we start by saying, well, sigma starts from when k is equal to 1, and we go up to when k is equal to n of that series 8k minus 11. And that's it. That's as easy as it is. It looks easy. It is easy. It's simply the sum of that series. All right. Okay, and then the next one, 3.3. Show that Sn is equal to 4n squared minus 7n. You'll see that now they've swapped back into n's. So we're going to use the formula. Sn is equal to n over 2 into 2a plus n minus 1 times d. We're going to leave the n as it is. A had a value of minus 3 and D had a value of 8. You simplify all of that out and you're going to end up with n over 2 into 8n minus 14. If you simplify within that bracket, multiply your n over 2 into your bracket and you end up with 4n squared minus 7n, which is exactly what they asked you to show. Okay, guys, we quickly want to get into the next one. I want to at least give you an idea of how to approach this one. All right, so 3.4 says another sequence is defined as Q1 is equal to minus 6, Q2 is minus 6 minus 3, Q3 minus 6 minus 3 plus 5. And what you'll see is that the end terms, the minus 3 plus 5 plus 13 plus 21, it's the sequence that we were dealing with just now. So when they say write down the numerical value for Q6, all we're going to do is the following. All right, so this is now for 3.4.1, and I'm very quickly just giving you the answers. You can work through them as well, but I want to give you an idea of how to approach them. Q6, so it's going to be all of the terms of Q5, which is minus 6, minus 3, plus 5, plus 13, plus 21, and then the next term in that sequence, remember with the constant difference of 8, is going to be 29. So that's your Q6. All right, we may just get through this one. The last question here, calculate the value of Q129. Well, here, we know that Q129 is going to be equal to minus 6 plus the sum of 128 terms of the sequence that we were dealing with originally. Look what I've done there. I've got Q1 is minus 6, all right? But all of the other terms, so it's that minus 6 that we're going to add to a sum which we've already been dealing with. You see that minus 3 plus 5 plus 13, we've already been dealing with that sequence. So I'm simply going to add minus 6 to the sum of 128 terms of that original sequence. So it's going to be minus 6 plus, remember, we've worked out that the sum of the general sum for the sequence is 4n squared minus 7n. So it's going to be minus 6 plus 4 times 128 squared minus 7 times 128. Plug that into your calculator and you'll get 64,634. All right, that felt like a marathon, but I really wanted to get to the end of that one and give you a little bit of help on how you can do this when you're practicing at home alone. And remember, it's practice, practice, practice all the way from now till you're perfect. Until next time, goodbye.